Hi everyone, welcome back. I'm Pratima Nayak. Today we'll be discussing the first chapter of class 11 mathematics of CBSE theory of sets. I have dedicated this presentation to George Cantor, the father of set theory. In this presentation, the main targets of our learning is about to describe a set, to represent sets in descriptive form, set builder form and roster form, to identify different kinds of sets, to understand and perform set operations, to use Venn diagram to represent sets and set operations, to use the formula involving number of elements in A union B and A intersection B, and other simple word problems. Instead of wasting time, let us come to the definition directly. What is a set? A set is a collection of well-defined objects. The objects of a set are called elements or members of the set. Now, what do you mean by well-defined object? Let us take some example. First case, I am taking the example tiger, bear, lion. Can you say that it is set of what? Yes, it is set of animals. In the second example, I have taken a banana, grapes and mango. So certainly we can say that it is set of, yes, it is set of fruits. In the third case, rubber, pen, book. It is set of, yes, it is set of study materials. Now when coming to fourth example, one tiger is there, one banana is there and one pen is there. So can you say that it is a collection of, yes, you cannot say it is collection of say fruits or collection of animals or collection of study material. So these elements are not well defined. So fourth example is not a set, but first, second, third are sets. Let us take some more examples. Which of the following collections are well defined? First is the collection of boys in your class, the collection of numbers 2, 4, 6, 10, 12, the collection of districts in Tamil Nadu, the collection of all good movies. Can you say the answer? Yes. The collection of all good movies is not a well-defined collection because for me, good movies are different, for you, good movies are different. And first three examples are collection of well-defined objects. Sets are named with capital letters A, B, C, etc. Whereas the elements of a set are denoted by small letters A, B, C. Reading notation. Belongs to is an element or belongs to. If X is an element of set A, we write X belongs to A. And if X is not an element of set A, we write X does not belong to A. Consider an example of set A. It contains 4 elements 1, 3, 5, 9 and we write set as A is equal to, within the curly bracket the elements are written. Here 3 is an element of A. So it is written as 3 belongs to A. 8 is not an element of A. So it is written as 8 does not belong to A. Next we will learn how to represent a set in different forms. The forms are descriptive form, set builder form and roster form. Let us take an example. The set of all vowels in English alphabet. In set builder form, it will be within the curly bracket all x such that x is a vowel in the English alphabet. In roster form, we have to write each individual elements. They are A, E, I, O, U. Next example, the set of all positive integers less than or equal to 15. So in set builder form, please note it will be all x so that x is an odd number, and in symbol it will be written as x is greater than equal to 0 and less than equal to 15. And in roster form it will be all individual, that is 1, 3, 5, 7, 9, 11, 13, 15. Next example, the set of all positive cube numbers less than 100. In set builder form, it will be all x is a cube number, and x is greater than 0 and less than 100. So in roster form, number less than 100 and cube, they are 1, 8, 27 and 64. In next session, we'll go for different kinds of sets. First is the most important, empty set. A set containing no element is called empty set or null set or void set. Please note the reading notation. It is denoted by phi, Greek letter, or a curly bracket and nothing in between. Consider a set A. The set of x is less than 1 and x belongs to natural number n. There is no natural number which is less than 1. So A is an empty set or null set. Now can you think of what is the number of element in a null set? The concept of empty set plays a very important role in study of sets, just like the role of number 0 in the study of number system. So can you think of number of element in empty set? It is 0. So we learned null set or empty set. Next is finite set. The definition is if the number of elements in a set is 0 or finite, then the set is called finite set. Consider the set X is equal to elements x such that it is an integer and x is greater than equal to -1 and less than equal to 2. So in the roster form, x is equal to collection of -1, 0, 1, 2, and number of element in x is equal to 4. So x is a finite set. So when the set is not finite, then it will be surely infinite. A set is said to be infinite set if the number of elements in the set is not finite. You can take the example of whole number. The set of whole number, which is represented by W, it contains the elements 0, 1, 2, 3, so on, and you know that there is no end of the whole number. So the set of all whole numbers contain infinite number of elements. So W is an infinite set. If we'll say about the cardinal number of an infinite set, it is not a finite number. So what is cardinal number? Cardinal number is the number of elements in a set. Next is equivalent sets. Two sets A and B are said to be equivalent if they have the same number of elements. Or in other words, we said n of A is equal to n of B, then A and B are equivalent. You can note the notation for representing equivalent set. For example, A has the elements 7, 8, 9, 10. B has the elements 3, 5, 6, 11. Number of elements in set A is 4 and n of B is also 4. So A is equivalent to B. Next is equal sets. Two sets A and B are said to be equal if they contain exactly the same elements, regardless of order. Otherwise, the sets are said to be unequal. In other words, two sets A and B are said to be equal if every element of A is also an element of B and every element of B is also an element of A. And the notation is same as equal sign. When sets A and B are equal, we write A is equal to B, and when they are not equal, we write A is not equal to B. Subset of a set. A set X is a subset of Y if every element of X is also an element of Y. And the symbol is X is a subset of Y. You can note the symbol used for the subset. Similarly, if all the elements of a set X are not contained in Y, then X is not a subset of Y. The symbol is given. It will be better if we give some example. Consider set X contains the elements 7, 8, 9 and Y contains the elements 7, 8, 9, 10. So every element of X is also an element of set Y. So X is a subset of Y. By symbol we write how it is written. Now for subsets, some concept we can remember so that it will be easy for us to learn more. Every set is a subset of itself. The empty set is a subset of any set. If X is a subset of Y and Y is a subset of X, then X is equal to Y. In converse, it is also written it that if X is equal to Y, then X is a subset of Y and Y is also a subset of X. Every set except phi has at least two subset phi and the set itself. It is proper subset of a set. A set X is said to be proper subset of a Y if X is contained in Y and X is not equal to Y. In symbol, X is a subset of Y. Y is called superset of X. So reading notation is given. You can note down. Now some example. Consider the set X is equal to 5, 7, 8 are the elements. Y has 5, 6, 7, 8 elements. So every element of X is also an element of Y and X is not equal to Y. So X is a proper subset of Y. Let us emphasize some concepts. Proper subsets have at least one element less than its superset. No set is proper subset of itself. The empty set phi is a proper subset of every set except itself. Phi has no proper subset. Phi is a subset of X if X is a set other than phi. It is important to distinguish between belongs to and subset. The notation x belongs to x denotes x is an element of x, and the notation x is a subset of y means x is a subset of y. Thus, phi is a subset of a set containing A, B, C is true, but phi belongs to A, B, C is not true. It is true that x belongs to set containing x, but the relation x is equal to the set x and x is a subset of set x are not correct because x is an element. Power set of a set. A set of all subsets of A is said to be power set of set A. The notation is P of A. The power set of a set is denoted by P of A. Now, take an example. Let A contains the element minus 3, 4. Then the subset of A are, first is phi. Phi is subset of all the sets. Then one set is containing only minus 3. Next is 4 and last is set containing minus 3, 4. Then the power set of set A is equal to P of A denoted is equal to 5 minus 3, 4 set and minus 3, 4. So please observe the syntax used for this notation. Next we'll learn how to find number of subsets of a set. First I am taking a set A which has no element or it is a null set. Now power set has only one element, that is 5. So number of element in A was 0 and number of element in power set is equal to 1. Now let us increase another number. That means B is a set. Now it has only element A. So power set B will be 5 and A itself. So please note number of element in set B is 1, whereas number of elements in power set B is equal to 2. Now let us increase another number. So C is a set which contains now A, B. So power set C will be set containing 5, A, B, AB. So number of elements in set C is 2 and number of elements in power set C is equal to 4. Let us increase another one. Can you guess? D contains A, B, C. So power set D will be 5, A, B, C, AB, AC, BC and ABC. So number of elements. Now what will the number of elements in power set and number of if the number of power set D is equal to set is M. 8. Now observe the table. If number of elements is 0, we have observed that number of subsets is equal to 2 to the power 0, that is 1. If it is 1, then 2 to the power 1 it is 2. If number of elements is 2, then it is 2 to the power 2, 4. If it is 3, then 2 to the power 3, that is 8. So the number of subset of a set with m element is 2 to the power m. And what about this number of proper subsets? The number of proper subset of a set with m element is 2 to the power m minus 1 because the set itself is not counted as proper subset.